going to do here is outline our general steps for running a hypothesis test for a single proportion. So our first step that we should always go through is setting up our null and alternative hypothesis. So for a single proportion, that's always going to look like, with your null hypothesis, your proportion just equals, and then some number from the wording of the problem. And then alternatively, your proportion, and again, you're going to prove that it's more than, less than, or does not equal that same number. And again, that comes from the wording. The null hypothesis is often some assumption or some baseline number. And in the alternative, this wording really comes through in the problems in terms of what they want to test or what they want to find evidence for. So this is what we want to find evidence for, what we want to prove. So that's our first step, is to set up those hypotheses. In our second step, we're going to go through checking conditions, and also something I like to do is just drawing a quick little setup of our hypothesis test. So checking our conditions, again, you want to check independence, you want to check randomization, and you want to check sample size. And with sample size, you're taking the sample size you're using times your proportion from the null hypothesis, and making sure that's more than or equal to 10, and taking the sample size times 1 minus that proportion from the hypothesis, and making sure that's more than or equal to 10. Again, that proportion should be coming from what you have written up in that first step. For the setup, some things I like to put together here is, well, you're going to have some sample proportions, so making sure you understand where that is, but also looking at your alternative hypothesis, which test are you running? So I would make a note of it being a right tail test. If I can see in the alternative hypothesis that more than symbol, and I would just draw a quick little picture to show that when I build this distribution and I find this test statistic, it'll land on this right-hand side, and it's this area to the right that's going to give me the p-value. Or, depending on what we have in the alternative, we might have a left tail test. And that'll come from having the less than symbol in there. And this helps me see that if I build this distribution and I have my test statistic of z, that I need to be sure to take the area to the left of it to get my p-value out. And then our last case is the two-tail test, which comes from having the does not equal sign. And with this, I need to be sure that when we build the curve, wherever my test statistic's landing, whether it's below or above, that we're taking the area on both tails. Which means you just find one of the tail areas and multiply it by 2. So with these hypothesis tests, you're only going to grab one of these, just because you'll only have one symbol here based on the wording of the problem. But this picture can be nice for once you find that test statistic and you're using technology to find that area, just making sure it's going in the right direction. Or especially with the two-tail test, it's nice to see this, so that once you find a tail area, you're sure to multiply it by 2 to get the correct p-value out. So that's our step 2, check those conditions, and just draw a quick little setup of how the hypothesis test will go. With step 3, there's going to be 3 pieces to this. We want to find our test statistic, then with that we can find the p-value, and from there we can evaluate that p-value. So first step in here is to calculate the test statistic. And the equation we want to use, it comes directly from the equation for a z-score. It's just with these proportions, what this is going to look like is taking our sample proportion minus the hypothesized proportion, all divided by, and this is where we get our formula for the standard deviation, but it's using the proportions from our hypothesis over our sample size. So using this, we'll get our test statistic out. Once we have our test statistic, then we can go and find the p-value. So finding the p-value, so here's where we get our z-score, and then depending on what test we're running, we want to create this area using technology. So use technology with our standard normal curve to create the area outlined in step 2 with our test statistic, with that value for z that we got here. Basically mimic the scenario using our standard normal curve. And this will give us our p-value. Once we have our p-value, we kind of want to do a quick evaluation. This is where we compare our p-value to our significance level. If our p-value is large, then we fail to reject the null. If our p-value is small, then we reject the null hypothesis. So from here, got that test statistic, go to technology to find that area under the curve, and once we have that area, compare it to whatever our significance level is. If it's big, fail to reject that null hypothesis. If it's small, we get to reject it. And from there, we can go to our final conclusion. And for our conclusion, there's 2 scenarios. We either fail to reject the null hypothesis, or we reject the null hypothesis. Our structure for wording is going to be pretty similar. What I use is, with each of them we're going to state the p-value. So with a p-value of, and then whatever the number is for our p-value. And then when we fail to reject the null hypothesis, the idea is we can't throw this out, so we don't have enough evidence to claim our alternative. So this is where we have not enough evidence to state that the alternative is true. So this is where we can bring in the wording of there is insufficient evidence for, and then what we finish with is just wording for the alternative hypothesis. Using the wording from the question itself to kind of piece together in context what goes right here. When we reject the null, very similar scenario, except we now have evidence. So when we reject the null hypothesis, that's where we're able to throw that out, and we know this is true. We have evidence for that. So we would still state our p-value, so with a p-value of, and then whatever our number is, there is evidence for, and then from there, we just put together the wording for the alternative hypothesis. These are the 4 steps that we're going to go through for every hypothesis